Good morning, everyone. I'm very happy that you took the time to connect with us at this very early time. So my name is Justyna, and I'm here with my two colleagues from the team, Martin and Florent, that will give you a bit more insights on our recently published SATCOM and GNSS user technology report. So I will have the pleasure to introduce, and then I will give the floor to Martin and to Florent to continue. So first of all, what is EUSPA? Maybe not all of you know us. So EUSPA is the European Union Agency for the Space Program. We are based in Prague, but also we have other locations like France and Spain. And we are part of the European Union governmental structure. We are responsible for operating Galileo and EGNOS GNSS systems. We work on GovSatcom hub, and we operate the SST help desk. We have a huge experience in security, working on security accreditation of the EU space programs. And last but not least, the three of us are working in the utilization part, meaning market development, downstream innovation, bringing the signals and technologies to the users. Let me see, how can I change? Okay, so when we look at our market and downstream innovation activities, there are the so-called three pillars on which we work. And the most important part where everything starts is the market and user intelligence. So we spend around €1 million per year researching the market, getting the data, doing econometric modeling to bring this knowledge to the users, to the geospatial community. So we have hundreds of companies that already use this data for their business planning, for their technology roadmaps. And today we will focus on the technology report, but if you look at our website on the publication section, you can see also the market report that is showing all the revenue trends, describing all the different applications of GNSS and Earth observation. And also we have numerous user requirement reports, which are showing what are the different performance requirements for GNSS, for Earth observation in all application areas. So please use this because we do it for you. It's really a huge investment, not only in terms of financial means, but also in terms of energy. And we are happy that more and more companies use it. But if you don't know these reports, please look at them. And based on this user knowledge that we gather, we help directly implementing the satellite technologies in the market. So this demand support is working directly with users like banks, insurance companies, energy companies, even fast-moving consumer goods producers, to show them that satellite data is something that can add value in the non-space sectors, help them to understand this value, and we do a lot of pilots, demonstrators to, in the end, reach the end user. And in the last bubble, the offer creation and innovation, this is the part where we co-fund innovation. So we are managing several R&D calls, but also, as I said, pilots, demonstrators. So if you would like to innovate with EUSPA, please let us know. We will be happy to support you and to guide you through your innovation journey. So now coming to the core of our presentation today, the GNSS and Secure SATCOM report. Why we publish it? So we publish it every 2 years to show what are the main changes, what are the main trends, and how the GNSS technology is developing. So Martin, together with his team that is working under a specific contract with us, is analyzing more than 600 models of receivers. So we really go from the bottom up. We analyze on the website of uBlocks, Hexagon, Honeywell, and Qualcomm, Broadcom, and so on. We check the specifications of the receivers, and we see what changed, what kind of frequencies they are using, what kind of constellations they are using, how they hybridize with other technologies than GNSS, how they write the specifications, what is new, what are the new trends. And so this is a huge work. We spent a couple of months to read through all those different specifications, and we summarize all that in the report. This year, for the first time, we added the part of SATCOM. And why? Because we are in a situation, and geopolitical situation, where we see that there is more and more use cases for this secure SATCOM in combination with GNSS. We are so used to having GNSS connected. So we have assisted GNSS, we have means to transmit the position, because it's not always us as a user that need to know where we are. It's also the solution providers or the asset managers that need to know where the assets are. They are not next to him. They are maybe in another continent, maybe in a remote area. Maybe we deploy, I don't know, a set of drones in some crisis situation, and we need to know where they are. So not always the ground infrastructure will help us in this. We need to ensure connectivity also in crisis situations to be able to transmit our location, to navigate systems, and this is where SATCOM comes into place. And we were also curious, if you need a SATCOM receiver and you need a GNSS receiver, is some integration possible at a certain point? How this market is reacting, how our market is reacting to that. And we will give you a short summary of our findings. So when we look at constellations first, you can see here on this chart that is very small, but I will explain you what is there. On the left side, you see this bar chart. The blue is GPS, the red is GLONASS, the green is Galileo, and the orange is BeiDou. So if you see, in the last years, we have more than 100 signals available. And this is the paradise for GNSS professionals. I remember still 10 years ago when we were dreaming to have 100 signals and all our problems will be gone, because we will have fantastic availability, fantastic continuity, and we can really work with all those signals. Unfortunately, there are still issues, so we didn't solve all the problems. There are still issues of disruptions of the signals, of cross-correlation issues, other things that now drive innovation. And maybe due to the geopolitical situation, we are not so eager to use all the signals. So there are other things that are coming into place. But still, I would say that this is an amazing area for innovation and amazing situation for GNSS to have so many signals to choose from. When we look at the capabilities of the receivers, we were checking the frequencies, the constellation adoption, which you see on the left side, and the frequencies adoption, what you can see on the right side. So in terms of constellations, we have now, if you add the single constellation, 2 constellations, 3 constellations, and 4 constellations, you see that the receivers that use only 1 constellation, which in most cases is GPS, is only 20%, which means that 80% of receivers now use multiple constellations. So the value of adding new signal is recognized, is used, and it's really the ultra low end of receivers that are very price sensitive and complexity sensitive that continue using only GPS. So this is, I would say, a success of multi-constellation, and compared to 2 years ago when we published similar report, the orange bar has increased. So there is all the receivers that adopted 2 constellations, 3 constellations now move to 4. So this is a very positive development. When it comes to frequencies on the right side, you see that still more than 60% of chipsets and receivers use only 1 frequency, which is normally E1, L1. And this is a surprise for us, because I have to say, when Galileo started broadcasting on E5, when BeiDou was coming with new frequencies, and even the L1 and GLONASS, when it was already showing the benefits, we were thinking that this 2, 3, 4 frequencies will grow much faster. And now we see that is not that fast. There is the benefit, it is observed, but it's not growing that fast. And there are many reasons for that. First of all, in our opinion, one of the drivers was to remove the ionospheric error. So using multiple frequencies, you remove the ionospheric error, and this is a benefit. It's true, but then we realized that more than 70% of all use cases, applications of GNSS happen in urban environment. And this is where the ionospheric error is not so important, because we have multipath, we have other sources of errors. So in reality, this ionospheric error removal was not such a big driver for those applications to go into second frequency. And then the other reason could be that the manufacturers, they try to still charge kind of the premium for the multi-frequency feature, because of course it costed them to adopt this new technology, these new signals. So we see that, for example, in premium smartphones, we have dual frequency. In low-end smartphones, we still have only single frequency. So it becomes kind of a differentiator in the market, that if you buy multiple frequency receivers, chipsets, that you have to pay a bit more. So this could be one of the reasons, but we still hope that these three smaller bars will grow in the future. Maybe one more argument could be that here you don't see the split, the percentage split is not of the sales volume, but is of number of models. So for example, one chipset of smartphone can be sold in millions, billions of quantities, and could be the dominating one and could be dual frequency, but at the same time is counted only as one model, while there could be 30 models for aviation or maritime receivers that are counted here as one of the 600s that I mentioned, and they constitute a bigger share, even if in reality, in terms of volume, they are smaller shares. So this 60% of models doesn't mean it's 60% of the quantity of receivers deployed. And here we have indeed markets like maritime, like aviation, that still use, in many cases, single frequency, also because of the very long replacement rate. So on the ship, you have one receiver that operates for 10, 12 years. In aviation, still the dual frequency mode is not fully available because of the certification requirements. So it doesn't represent maybe what we observe in our life, your life as surveyors, as application developers, where you have maybe more something to do with the dual and triple frequency. Okay, moving forward. Very big trend that we observe is this focus on removing the GNSS vulnerabilities. Here we are mentioning only a few things what can be done to make the receiver more robust. You can read more about this in the report, but this is a big trend. We are observing more interference, more jamming, more spoofing, and we need to make sure that our receiver can operate in difficult environments. And there are many methods to support this. We are listing here clean RF environments. So very important thing is to monitor the jamming and spoofing phenomena on a larger scale. And this is already happening, especially around airports, around sensitive areas. But it would be also useful to have a regular monitoring service on a larger scale, where we can identify interference and jamming that is fixed, that is out there, and we could eliminate it, because maybe it is not a malicious attack, maybe it is something that is simply interfering. Very important point, antennas. So antennas that have better signal to noise ratio, that are more performant, that help to avoid multipath effects. Strengthening GNSS itself. So there are techniques that you can deploy that are anti-jamming, anti-spoofing, of course, including also the OSNMA new service of Galileo. But I believe that the big trend now will be to use the machine learning and AI to better distinguish which signal is the, let's say, unwanted one, and which one is the one that we would like to use. Here, very important point could be also the developments around 3D modeling, around maps, and knowing if we see the satellite, is it possible that I see the satellite if I receive a signal from it? If I have a 3D model, I know where the buildings cover the sky for me, and I know that if I see a satellite from behind the building, it must be reflection. So there are also many techniques beyond the receiver and GNSS. And then last but not least, it's an obvious one, diversifying sources of PNT information. So make sure that your receiver is able to receive multiple constellations, multiple frequencies, and this will protect you from vulnerabilities. Okay. My last slide on trends. I will go very quickly because we have still some things to cover, but very big topic is also the complementary PNT technologies. Of course, in the receiver, you can in your solution, you can integrate other things that makes the whole solution more robust. And this is integration with IMUs, with visual sensors, and so on, with quantum. What we don't see yet is the integration with satellite data. Of course, the revisit time does not allow at this moment to have this full real-time contextualization of where our receiver is, but maybe in the future we can also integrate with satellite data. And then maybe I could mention here also some innovative signal processing techniques. And I could say that with Galileo, we are working on a new quasi-pilot signal that will enable much faster acquisition and will help to reduce time to first fix.
I will hand over from here, and I will give some insights into the 5 receiver families as we defined in the report, but mainly I will be making references to the report itself to really invite you to read it more in depth and carefully. So this will be just a snapshot of what is there on the 5 families. So basically, there is a big section where we dedicate place to the 5 families of GNSS receivers. We divide them by the main features into these 5 groups. That is the mass market entry level family, which where you can find the low cost of everything, low cost smartphones from the consumer solutions, or Internet of Things devices, where the power of the battery is the main interest, tracking devices, PLBs, the personal locator beacons, or drones. Then there is the mass market premium. I will talk a bit more about that, so I will save the time here. Then the other 3 remaining ones, professional, non-regulated. Of course, this is also, it can be called high accuracy family, where of course you have the geomatics and agriculture, the high top, the most accurate, and the really the top receivers from the point of availability, accuracy, and all the KPIs. The professional regulated, that's a group that contains receivers that are mainly deployed in the safety critical use cases. So you can find there the receivers from aviation and some for the drones, maritime and inland waterways, rail. You can think of there on the automation use cases associated with train control and for the future of the signaling and traffic management even. And also for automotive or insurance and finance. For that, we mean the timing and synchronization devices in banks, for example. And the last group or the last family is the special applications one. Whatever did not fit into the previous 4 is actually there, and we are featuring there the two niche examples, which are the space receivers and the continuously operating reference stations. And for all these 5 families, the report really contains a deep insight into of course, the characterization of the family and the listing of the use cases, but also the industrial landscape, listing the main manufacturers from the families. Then the KPIs that are the main important ones for each of the groups, so that you really in the end understand what we mean by that receiver family. Then the famous statistics that Justyna already mentioned, but this time for all the for each of the family. Then typical state-of-the-art receiver specifications, and then sample products from innovative receiver manufacturers, so that you really could have a very good understanding what is within each family. So as I said, I will guide you through the mass market premium receiver family. Talking about the main use cases or segments of applications, by the way, we use the terms use case, and what we mean here is we refer to the way a GNSS receiver may be packed and utilized in practice, which may come in the form of a type of application, a group of applications, a service, or even a GNSS capable device. So basically, that's what we mean by the use case. It's more loose term than we use, for example, in the market report when we talk strictly about segments and applications. So here is more loose, but to in the end to have a clear in the end definitions of or of the families. So yeah, consumer solutions, high end, everything, smartphones, tablets, wearables. But also we included in this family the general aviation, non-certified, non-safety critical transport receivers devices in this let's say use case, automotive, but the premium devices, and you already mentioned infrastructure, but uh, again timing, but where it is really where it is higher end devices that use more than one frequency usually. Representative sample of products there. It's really just to give you really the idea what type of devices we talk about, but it's really just for you to get the better understanding. Looking at the similar charts that Justyna presented, but here we have even further two additional types. But what I would like to highlight here for the mass market premium is uh, what is interesting at the bottom is actually that there is that 80% plus devices support multiple GNSS constellations, and 65% roughly supports all four. And our quite takeaway from here is that even though okay, still the signal frequency is the most common configuration on the left bottom, there is a growing trend towards dual frequency, mainly L1, E5, and 10% even supporting triple frequency. And as I just repeat and echo what Justyna was saying, that of course this is really just it is from the point of view of the product or from a device type. So each product is weighted equally. And there is also, let's say, long cycle of replacement, and of course we are keeping the products in the statistics when it is still available in the offering of the manufacturers. So it might be tweaked, biased by the fact there are products that are maybe soon to be out of the market still. They are still in the statistics when still offered by the manufacturers. And just to say what could be a characterization of the mass market premium, a lot of them are capable of tracking and then decoding full navigation messages. What it means that they are ready for the implementation of advanced services. For example, Galileo early warning service. Okay, let's have a look now quickly at the comparison with the mass market entry level. As you can see, there is higher support for the L1 frequency, and this is actually the market which, together with the professional regulated one, which contributes mainly to the L1 only devices. GPS support, GPS only support is here higher than in the premium. It's almost 30%. When going back to the let's say the navigation message continuous tracking, those devices are typically not providing that on continuous basis. And so forth. I leave it up to you then to explore the charts and these and the let's say, insights into it. So let's wrap up for the mass market premium and adding them some more, let's say, typical specifications. These devices support more than one frequencies or more additional frequencies. That's definitely a trend leading to the access to the advanced technologies of augmentation services, like RTK and PPP. I mean, everyone of you knows what these are, but yes, that's how you can also characterize this mass market premium when the device have those features. It's within this family. What the devices also offer, if they offer dual frequency, it is quite often in configurable design. It's up to the system integrator to decide which combination of frequencies they wish to deploy. Then talking about the mobility devices within the family, as they operate in high-speed environments, there's a high update rate needed, and because they are being integrated with other devices like accelerometers and gyros, they have better performance, but it's at the cost of the power consumption. So yes, most of the premium products, meaning the devices in the family, they offer upgradable features through firmware updates, but it's up to you and to decide and in the end pay a bit more for that. And what is also quite common is that there's the use of the omnidirectional embedded antennas that is quite visible seen.
So good morning all. Okay, so during the course of the next few minutes, I'm gonna make an attempt to give you a fair glimpse at some key facts or content that is part of the SATCOM section of the report. And I decided to focus my segment on basically two main topics. The first one will be the SATCOM user terminals and the trends that we see happening in this area. And what we call actually user terminals is the equivalent of the receivers in the GNSS world. And then I will touch upon the synergies existing and upcoming between GNSS and SATCOM. So yeah, let's start with the user terminals. And as you can see, we decided to group or to segment the pool of SATCOM user terminals into three main large families. The communication on the move and communication on the pause terminals, the deployable, handheld, and secure IoT terminals, and the third group is the fixed and backhauling user terminals. And you can see some illustrations of these various user terminal types in order to give you an idea of, first of all, what they look like. And I'd like to highlight the fact that obviously the pictures are not at scale. But I think what you can easily imagine is that the size of the SATCOM user terminals is linked to basically the platform it is on. And there is some important size constraints, especially on the mobile platforms, such as plane, cars, vehicles, vessels, and for the handheld as well user terminal. There is less size constraints when it comes down to fixed or deployable terminals. So what can we do with those SATCOM user terminals, or what do they enable? And I'm going to pick, let's say, two examples to bring this a bit to life, to make it more tangible. I will start with a use case coming from the crisis management segment. So usually after an event, either man-made or natural disasters, we have the classic terrestrial network which is down. And to support the first responders in their relief mission, these users, this community needs to be able to communicate. And as a result, once on site, once in the area where this event took place and brought the terrestrial network down, this community needs to reestablish, one of the first things that they need to do is to reestablish a mean of connectivity. So usually what they do is to establish what we call a connectivity bubble, which is basically a way to establish a command and control center to orchestrate locally the release response. And in this specific instance, they will use a fixed user terminal alongside most likely a come on the move user terminal to enable the troops on the ground to actually scout the impacted area. So you're talking here about mobility applications. And as a result, the type of user terminals that needs to be used needs to be compatible with this requirement of mobility. A second example could be around maybe something quite familiar, is what we call the last mile connectivity. So we have the telco operators, such as Orange, Telefonica, Dutch Telecom, that sometimes want to expand the coverage of their terrestrial network. And for them, depending on the area where they want to extend this connectivity, it doesn't make financially sense to actually roll out the terrestrial network because the density of the users or their customers doesn't enable them to close their business case or financial investment in terms of return. And what they can do is to leverage on SATCOM connectivity in order to connect the base station, so basically the relays that so these towers with some relay antennas to connect these relays from this remote or less dense areas back to their core network through a satellite link. And there, to achieve that, a use of fixed user terminals connected to the base station is actually the way to go. So now, if we talk about the technology trends that we see happening. So first of all, we can see across the board, regardless of the technology, the user technology types, the push from the users to benefit from the multi-everything enabled user terminals. And probably what you need to know, depending on your, let's say, exposure to the world of SATCOM, is historically the satellite operators, so those owning and operating some satellite constellations, have developed a closed architecture or a proprietary system, which means that you need historically one UT per constellation and per satellite operator. And this and the market is shifting from this closed environment to a more open architecture because of the push from the users to benefit again from multi-everything enabled terminals. So multi-frequency, multi-orbit, and multi-constellation, not to be tied to actually one single satellite operators. So this is what we see across the board. Now, if I try to pick, let's say, a main trend per now families or type, if you look at the come on the move / come on the pause family, the major trend I would say is with regards to the reduction of the swap, the size, weight, and power requirements of the user terminals, because like I've already mentioned at the beginning of my presentations, space on where you need to install these terminals matters, and therefore there is a need to reduce actually the footprint of those terminals for those platforms.